Polynomial system of equations. Solving a system of equations can be done by looking at the graph and finding the intersections of the two functions. The intersections are the solutions to the system. Now, if I say we're gonna graph an equation, we're just going to graph one equation. But if I say we're going to look at a graph that's a system of equations, a system means two or more equations. Now today we're only going to be dealing with two. So when we look at this graph, we see that we have a quadratic function which forms the parabola, and we have a linear function which forms the line. That's why it's called a system of equations, because there's two equations. Now, where they intersect is the solution to the system. So how many solutions are we going to have for this one? How many intersections are there? Two. They intersect here and they intersect here. This intersection, to get to it, you have to go left 3, and then you don't move up or down. So its solution is negative 3, 0. This intersection, you have to go right 5, up 8. So the solution is 5, 8. Now with the next one, we're still dealing with a quadratic function, which is a parabola, and a linear function, which is a line, but this time there are how many intersections? 1. And to get to that intersection, you go right 2, down 6. So that's why the one solution is 2, negative 6. Okay, then the third scenario is when they do not intersect at all. And so if an intersection is the solution, no intersection means no solutions. Any questions so far? Okay, let's try a few together. Let's look at number 1. List the solutions to the following systems of equations. Well, for this one, how many solutions are we going to have? 2. 2 solutions. One right here and one right here. If we're looking at this one to the left, what would its coordinates be? Negative 3, negative 8, right. Well, the graphs aren't great, but look, if you see this is negative 2, negative 4, so negative 3, and then down 8. Okay, what about this second solution? What are its coordinates? 2, negative 3. Okay, then let's go down to number 4. Number 4, how many solutions do we have? 0. 0, right, but instead of writing 0, because 0 is a number and you don't want somebody to think you're saying they intersect at 0, you write no solutions, or you can put none. Okay, now turn to the next page. Okay, for number 7, how many intersections do we see? 3. Okay, so there's going to be 3 solutions. So starting at this far left one, what is its location? Negative 4, negative 4. Okay, what about this other one? Negative 1, 0. And what about the one on the top right? 3, 6. Okay, now, you'll be able to have time in a few minutes to go back and finish those other ones if you didn't already. But now you need to pay attention because we're about to learn topic 2. Okay, so pay attention. This time we're going to solve a system of equations with the graphing calculator. So you can see this time we were given the equations instead of the graph to look at. So basically we're just going to put them in the calculator and look at the graph. So step 1 is put both equations in. And you'll do that using y equals, just like always. Now you'll put the first equation under y1 and the second equation in y2. And then once you have both equations typed in, you will hit graph. Now, once you graph them, you'll see the picture and you'll be able to see where the intersections occur, just like we were able to on these previous problems. But to find the exact location, you're going to hit second, and then after that, trace, and then after that, you'll hit number 5, because the word beside number 5 says intersect, and that's what we're looking for, is where they intersect each other. Now, once you've hit second trace 5, you'll see a little blinking cursor on your screen. You're going to move the cursor to the intersection. No, it doesn't matter which one you start with. And once you've placed your cursor on top of the intersection that you're trying to identify, you will hit enter 3 times. And then it'll pop up your solution. And then to find the other one, you go through the same process. Second trace 5, move the cursor to it, enter, enter, enter. Okay, so I'll give you time to finish writing that, and then we'll try it on the calculator. This is pretty easy. Okay, so let's try it. Y equals x squared plus 4x plus 4. So what kind of function is that? So it's going to form a, what's the parabola, right? And then our second equation is what kind of function? Linear, so it's going to form a line. So let's graph it and see where they intersect. Okay, so we see the intersections, but to find the locations, we hit second trace intersect, and this one's already, did yours start on that intersection? If it didn't, you just use your cursor to get to it, and then you hit enter, enter, enter. And so it says the intersection's at 0, 4. So that's our first intersection for this one, 0, 4. Okay, then to find this other intersection over here to the left, you have to hit second trace again, intersect. You have to let it know each time what you're wanting to do. Now let me show you something. Everybody look at the board. This could save you time. Okay, say the parabola is a pretty large parabola and it goes way down here. When you start moving, I mean, that could take a long time to go down that parabola and back up, correct? Well, mine's a little easier to tell which function you're on because it's color. See how I'm on the blue function and everything's lighting up blue? Well, if I hit up, it jumps onto the red function, which is the line. Now, your calculator will do that too. It's just harder to tell because yours is all black and white. But you'll be able to tell once you hit up that now yours is on the line. And now it's just quicker to move over to that intersection instead of going down the parabola and back up it. Which for this one, it wouldn't have taken that long, but for some parabolas, it would take a while.
Take a 4, 4.
Okay, so enter, enter, enter. Our second solution is at -4, +4. Okay, now, so we see why these are the solutions graphically, because they're where the functions intersect. But let's talk about why they are the solutions in, like, algebraically. Look at this. This is a ordered pair, right? So this 0 is actually the what? The x value, correct? And the 4 is actually the y value. So if I take the 4 and put it in place of the y, if I take 0 and put it in place of these x's, what's 0 squared? 0. What's 4 times 0? 0. So you end up with 4 equals 4. Is that a true statement? Yes. So this point worked in this first equation. Now let's try it in the second. In the second equation, the only place to plug in something is right here, y. Well, what's the y value of this point? 4. Okay, is that a true statement? Yes. So that's why this point is a solution, because it worked in both equations of the system. Now let's look at the other point. Okay, it's an x value and a y value. So in the y place, I'll put +4, but in the x places, I'll put a -4. So what is -4 squared? 16 plus, what's 4 times -4? And then don't forget about that +4 that was already there. What's 16 plus -16? It cancels. So all you're left with is 4 equals 4. Is that a true statement? Yes. Then if you try it in the other point, the only place to plug in is y. Well, our y value for this point is 4. 4 equals 4. True statement. So algebraically, that's why those are solutions, because they are the points that when plugged in both equations of the system, they make true statements. Okay, so now let's try one together. Let's look at number 1. What do I do first? Graph them using y equals. So I'm going to clear out the previous equations. What is that first equation? Right, x squared plus 3x minus 10. And what's the second equation? Okay, so again, we're dealing with a parabola and a line. How many intersections do you see? 2. How do we find them? Second trace, intersect. And then, right now, look, the thing's way down here. So I could hit right and bring it all the way up the parabola, or I could just hit up, jump up to the line, and then I just move a few places over until I get to the intersection. And then once you're on the intersection, you hit enter 3 times. And so the intersection is what? 2, 0. Okay, now we have a second solution. So again, we hit second trace, intersect. Okay, it's way over here, so I'm just going to move it. Well, you can do it that way, or you can go to the line and go down, whatever you think is faster. I went too far. Okay, so enter, enter, enter. So my second solution is at -4, -6. Now remember, the reason they're the solutions is because when plugged in, they make true statements. They have to make a true statement in both. Like 2, 0 has to work in both of these. And -4, -6 has to work in both. If it only worked in one, it's not a solution to the system. It has to work in both to be a solution to the system. Okay, I'm going to give you a couple of minutes to finish up 2, 3, and 4, and then to go back and finish any of this page that you didn't finish. And then up here, number 8, it shouldn't take you long. A lot of you have already been doing it, and then we're learning the last topic. Okay, so just a couple. Okay. Multiply x plus 5 times x minus 3 times x plus 7. For just a second, pretend that the x plus 7 isn't there, and then you obviously know what to do. What do we do? Correct. So x times x is x squared. X times -3 is -3x. 5 times x is positive 5x. And positive 5 times -3 is -15.
Do you want to erase that x plus 7?
Yeah, just for a second. Now what do I do?
Bring the x plus 7 back.
Okay, but before that, what can I do to this?
Oh,
Correct.
simplify.
That middle outside and inside term will become a positive 2x. Now that we've done that, we can bring back the third binomial, x plus 7. Okay, so I'm going to write it down here. And now I'm just going to distribute the trinomial times the binomial. Now, it looks like it might be difficult, but it's really not. All you're going to do is you're going to start with the x squared, and you're going to multiply it by the x and the 7. So let's do x squared times x first, and what is that? And then x squared times 7 is 7x squared. Oh yeah, that's just the first part. Now that we've distributed the x squared times both parts of the binomial, we're done with it. And now we can move on to the 2x. What's 2x times x? 2x squared. What's 2x times 7? Right? And so now we're done with the 2x. Now what do we do? Right, -15 times x is, and then -15 times 7 is, right. So now I'm finished distributing, because I distributed the entire trinomial times the binomial. So now what do I do? Right, and so how are we going to do that? Combine like terms, right? So x cubed is the only cubed term, so we just bring it down. Right, the x squared terms combine to 9x squared. The linear terms become minus x, because 14 minus 15 is -1, and then minus 105. And then that's your final answer. That's all you do. Okay, so now you need to work the other 4 problems on this page. Tomorrow we will learn the last lesson, and I'll also hand out their test review. Thursday we'll have a 10 square over pages 13 through 25, and we'll go over the test review, and then Friday, of course, is the test.